Okay, so we're going to start talking about the first of our four biological macromolecule type, and it's carbohydrates. And this is, as most people would know, carbs. They'd say, oh yeah, I'm going to be carb loading today, I'm going to eat a lot of pasta. So what does that mean? Maybe you didn't know that pasta, bread, it's just a whole lot of sugar tied together. So with carbohydrates also, if you think about the name, carbo meaning carbon, hydro meaning water, carbohydrates only are composed of carbon, hydrogen, and oxygen, water, right? Carbon and water. So that's where the name comes from. And I had mentioned before, I'd said that a common sugar, the primary blood sugar in you and I, it would be glucose. And we had said that formula, C6H12O6, is the formula for glucose. And if you notice, in all carbohydrates, you will have a 2-to-1 ratio from the hydrogens to oxygens, because remember we said water, H2O, H2O. And so this is a simple sugar here. Now, the stuff that you put in your coffee would be what we call a disaccharide, and that's where you have two sugars, monomers combined, two simple sugars combined into disaccharide, 2-di. And so if you even look at the formula for a disaccharide like sucrose, it's C12H22O11. Oh, look, 2-to-1 ratio. You see? And so most people know, if you think, and you can even then have polysaccharides. That would be things like starches. And that would be some gigantic formula, right? Because it would be many of these monosaccharides put together. So when you eat the pasta, when you eat your bread, and anything that's starchy, it's really just a whole bunch of sugar molecules. So what do you think the function of a carbohydrate is? Energy. Energy is one of the major functions. It also is made up parts of cells, and like I said, even energy, stored energy. When you may know somebody who has diabetes, and what is the problem with diabetics? They have high blood sugar. Now, if you're not diabetic, you don't have high blood sugar, but on occasion, you eat a whole lot of sugar. You go to Olive Garden and you eat that giant bowl of pasta, and now it's a giant bowl of sugar. But your body is able to take the excess sugar out of your blood and put it in your liver in a polysaccharide. It builds this big molecule to store the excess sugar until later in the day, when you've been running, you said, oh, I ate all that pasta, I need to exercise. And so you're using blood sugar, and it starts pulling some of that sugar out of the glycogen, the polysaccharide stored in your liver. All right, so we have monosaccharides that can be put together with another monosaccharide to make a disaccharide. And in both cases, it's going to taste sweet. You put the disaccharide saccharin in your coffee and you say, oh, so sweet. And if it was glucose, you would say the same thing. What if you put potato or bread or pasta? Not sweet. Polysaccharides they're just sugars, but they don't taste sweet. Your taste buds in your mouth detect mono and disaccharides and send a signal to your brain saying, oh, so sweet. And there's different kinds of disaccharides in your notes. We have a maltose, that's brewer's sugar. It's two glucoses together. Lactose is milk sugar. It's a glucose and galactose Remember, we said this can be put together in a lot of different ways. It can be put together one way as glucose. In another organization, it can be put together as galactose. Or in another version, it could be fructose, fruit sugar. And so we have the mono and disaccharides taste sweet, and they either consist of one sugar unit or two. I'd better, let's see. So we had said, I'm just going to show this picture on the thing here. So you'll want to look at this very carefully. I'd said we have those ring structures. Each of those ring structures are a monosaccharide. And you can see if you follow it to the right, they're going to be put together as a disaccharide. And you notice it says plus water. I hope it does. Where would it say it? Yeah, so up here on the arrows, it shows the water coming off. And then we had said, and that's a dehydration synthesis. And so you have a hydrogen from one of those ring structures and an OH from another one, and they combine together, and the hydrogen and OH go off as water. And then when you break them apart in a hydrolysis, a decomposition, you have to have water to cover up those empty places. So it's a dehydration synthesis that builds the disaccharide, and then if you keep adding to it, it will become a trisaccharide and a polysaccharide, meaning many. And you and I, we have long chains of sugars in our liver that we had said functions as a quote-unquote long-term energy storage. But when I say long-term, I mean 4 hours. I don't mean 4 months. That's a different kind of molecule we'll talk about, which is a lipid or a fat that we, when you gain weight, you don't say you became sugared. You say you became fat, lipids. So the polysaccharides are just a whole lot more of these sugar units. Okay, I'm gonna stop right there, and we'll talk about nucleic acids, the genetic material, next.